So, I will continue discussion on the basic tools and instruments in the laboratory. So, I was discussing about the cathode ray oscilloscope CRO. So, that CRO, this is the intensity knob, you can change the intensity of these lines, display, that is basically tracing of electron beams on the screen. So, you can change the intensity of this display. Okay, this is the focusing, this is the focusing, you can focus, makes this line very sharp. Okay, and there are x shift you can change along the x, along the y. Okay, so this is the y shifted, because here this two channels are there, channel 1 and channel 2, these two are independent. Okay. So, this is the y scale, this is the voltage scale, I can change the voltage scale. So, that is the, you can see y. Okay. So, y it is not changing because I have to select this channel 2. So, here option is there. So, I select channel 2, then it is channel 2 is active, and this there are dual mode, both I can see together. Okay. So, one is for channel 1 and another is for channel 2. Okay. So, let me keep it here and other one let me keep it here. Okay. Okay. So, you can shift along the x axis, along the y axis. So, along the y axis there are two scale, okay, two channel. So, both channel you can see together, both channel one after one another. So, now one channel you can make active, channel 1, other one make active. So, you can select channel 1 or channel 2 or dual both. And that is for time, x axis is a time scale basically. This you can change the scale using this one. So, time is related with the basically frequency, and amplitude is related of the with the voltage, volt for a signal. Okay. So, now let me give a signal to this CRO, and so these are BNC cable, these are actually this connection, coaxial connection you can get, very nice connection you can get using the BNC cable. So, this is the BNC cable. So, I have given it's a now it's a channel 1 is selected. Okay. If I select channel 2, so it's nothing, no signal is there. So, channel 1 there's a, so from here, as I told, how to find out the voltage, how to find out the frequency, you can get from this scale. Okay. So, now today one thing I will see triggering. Okay. Here this basically auto triggering, and this triggering level, let me just take down this one, triggering level, at which level it should trigger, start, it should the signal starts at which level. So, that this is basically triggering level. Okay. So, here is a auto trigger, we have kept it as a normal mode, it is a auto trigger, it is triggering automatically. But if I want to select that triggering should start at particular phase, then at means at which level I want to trigger. So, I have to use this one basically. Okay. just paste, sorry, yeah, I have to press it. So it's a I think I can choose the triggering level. So here level is there. So here you can see, if I change this level, you see, okay. So at which, here you can see at starting point should be where that I can select, okay. Okay. Starting point should be just here. So it will start, I think, yes. So starting level you can basically you can choose starting level, you can choose starting level, you can choose. So I can choose this the starting level, okay. So at this level, so when signal are coming, so always it will, the starting point will be this, okay. So triggering will start at this level. So that's manually one can select. So for measuring the phase of phase difference of the two signal, so this can be, so just taking the another signal. So here just comparing these two signal, one can find out the phase difference between these two. But to find out the phase difference between these two, it's we use different method. It's called, that is basically the superposition of two waves along the x and y direction of same frequency, okay. So you will get the basically Lesage's figure, and then from Lesage's figure you can see the Lesage's figure, you can find out the phase difference, okay. So that I will discuss. Other way, if you can, this the one, another one, if you take, if we can hold them, then you can see the phase difference between these two, but these are not the good way to do that. So using the Lesage's figure method, it is easy to find out the phase difference between two signal, as well as one can find out the frequency ratio of the two signals. So basically that I will show you today, okay. So here this is the signal, one signal, its amplitude is here, you can see this 8 volt, amplitude is 8 volt. Here I have kept at 2, so it is 1, 2, 3, 4 divisions, so 8 volt, each division is 2 volt. And then I will take the second, signal. So that signal is at channel 2. So now it is at channel 1. Now I will select the channel 2, okay. So this just take me at the middle, okay. And here it is also at 2, this channel 2, this scale, I have selected this 2 volt per division. So here you can see it is 2.5 division, 2.5 more or less. I have to take slightly up, then you can see, but it's 2.5. So 2.5 division, 2 volt per division, so it is 5 volts. So here you can see this is 5 volt. I think I will choose back. Yeah, you can see this 5 volt, but that is 5 kilohertz. That frequency of this signal is 5 kilohertz. That also one can find out, as I discussed earlier, okay. So what is the this starting from here to this way? It's the 1, 2, I think 2.5. Here what is the, here it is 0.1. So as I told, here 0.2 showing, but it will be 0.1 because it is somehow distorted, this knob. So 0.1, here it is it's a 2 division, I think. Yeah, always I take time. 1, 2, 2 division. It will be 2 division, okay. So 2 multiplied by 0.1, 0.2, so 1 by 0.2 is 5. It is in milliseconds, so it is kilohertz. Okay. So that I have discussed. Now if I take these two signal, what is the phase difference? These two signals are having the same frequency. So then what is the phase difference between these two if I want to find out? So as I told, I can see these both, but I can see the both signal. Okay. So I have put in dual mode, both signal I can see, but you can see they are not fixed. Okay. One is slightly changing because this high volt, somehow this, if slight fluctuation of the frequency, so it may change. So at lower frequency, this generally we don't see this type of movement. So so as well as this is not the good way to measure the frequency, measure the phase difference of two signals, but using the Lissajous figure it is very convenient. So Lissajous figure, you know this, I think I should tell you slightly about this Lissajous figure. You know this, for that only we need basically dual beam oscilloscope, means two channel should be there, dual mode, dual beam oscillators, okay, CRO. Now here you can see that when you will get the Lissajous figure, so one signal you have to put along the x axis and another signal you have to put along the y axis. Okay. So in CRO, basically for a particular channel, whatever signal we are seeing, so x is automatically, it is time axis and y is voltage axis. Okay. So now in dual mode, basically not dual mode, in when we put this signal to channel 1, so that means this voltage, this voltage here, xt means it's how voltage is varying, Vt. Okay. That voltage variation along the y axis is shows as a function of time, but there are option in the CRO that is called XY mode. Okay. So when you will use the XY mode, means two signal you are putting in these two channel. So one will be applied, one x axis will be, for x means x axis will be voltage axis and y axis also will be voltage axis. Okay. So time axis, it will be this time axis, time that one will not work. So this is the for time, it's always for x axis. This is the voltage for channel, voltage along the y axis for channel 1, this is for channel 2. Okay. But in XY mode, so this time axis will not work. Okay. So only this channel 1, it will act as a, say, x voltage will be applied along the x, and here y voltage will be applied along the y. Okay. So that is called XY mode. So that option is there here, XY mode. Okay. So dual, so if you use the XY mode, then for these two signal along the x and this is the along the y, and from there basically if fx and fy is same, then what will happen, depending on the phase difference phi, so if phase difference phi is 0, then you will get straight line, okay, and then it is for 180 degree it will be just opposite, 90 degree it will be ellipse or circle. So whether ellipse or circle, it depends on the amplitude. If both amplitude are same, then it will be circle, otherwise it will be all the time it will be ellipse, okay. So 270, it is one is left handed and another right handed circle or ellipse, okay, and for other than this angle it will be ellipse, okay. It will be ellipse. Now from the ratio of a axis and y axis one can find out the phase difference between these two, that is phi, okay. So this is the method one can find out the phase difference between the two signal of same frequency, and if frequency are different, then basically one can find out the ratio of the frequency of the two signals. So here we will see the multiple loops in the Lesage's figure. So depending on the number of loops, basically one can find out the ratio of the frequencies of the two signals. So if ratio is 1:2, okay, so this kind, depending on the phase difference, this kind of things here you see, these are as if this you are getting this line. So this type of phi 0, for phi equal to 0 you will get this, for phi equal to 45 you will get as if this, and for 90 degree you will get this type of thing, okay. Two loops, you will basically getting two loops, okay. So this you will get for 1:2, okay. So along the x and along the y, if you see this how many loops are there, okay. So depending on that you will get the so this is it will be equal to the ratio of the number of loops along the x axis and along the y axis, okay. So that way one can find out the ratio of the loops using the Lesage's figure. So that just I will show you how to. So here nice things you see that somehow these two, you see these two, now they are in same phase. Now this phase between these two are changing. Here I can see. Why it is changing? Probably some fluctuation somewhere is coming, so that's why it changes there. That I can see in this arrow. Now if I use them, this XY mode, you see these two means one signal is along the x and another signal is along the y, then these two are of same frequency but amplitude are different. Amplitude is here 8 volt and there 5 volt, okay. Now what, so in XY mode, as I told, one signal will be along the x and another signal will be along the y. There will be superposition and you will get the resultant pattern, and that is basically Lesage's figure. And then you see nicely I can show you when they are in phase, as I told, you will get the straight line. Immediately I can show you, you are getting straight line, and that it is changing. See, since this one was moving, so this phase is changing, you see, just you see 90 degree, phase difference 90 degree, phase difference 0, phase difference 45, phase difference 90 degree, phase difference 180 degree, okay, phase difference 0. If we, okay, now 90 degree phase difference 0, okay. Now when I can show you this, you see, now you will see the 90 degree, just it is, you see, it's a 90 degree, phase difference is 90 degree. Now they are in phase, I can show you they are in phase. When they are in phase, just if I put they are in phase now, I will see this is that line. Now I will just they are in out of phase. They are in out of phase 180 degrees. So I was getting this way. Now again they are in phase, you see, they are in phase, you are getting straight line along this. Okay. So it is not the way to do, but somehow here one is the I think this initial phase, this phase difference is omega, here both are same, but these two are not same source. Okay. If there slight change is there, okay, between this omega t, okay, omega t plus phi. So if slight change is there between omega 1 and omega 2, so omega 1 minus omega 2 into t plus phi, so del omega t, okay, if that del omega is not 0, then you cannot get the constant phase difference phi. So that's why, since these two are different source, okay, so here it is showing exactly same, but if slight difference is there, so del omega will not be, hopefully I am able to tell you properly, okay, what I am trying to say, that so one signal it has, as I told, omega t plus omega t, and another signal omega also, this is say a omega b omega t plus phi, right? This sign etc., whatever this is there. Okay. So for same frequency this should happen, that was I was telling. So if so then only this the phi will be there, but if slight difference is there, these two, okay. So phase difference, basically this is the phase difference, okay, or this can be minus whatever, okay, this is the phase difference. But when these two 0, so only this it's a remain constant. But if slight difference is there, so this delta omega t minus plus minus phi or whatever, okay, so this will be the phase. So this, since two different sources I am using, so this, I think this del omega is not, this omega 1 and omega 2 are not exactly same, okay. So that's why, and this is also high frequency, 5 kilohertz. So in lower frequency it does not happen. So reason I could tell you why this slight shifting is there, but that I am using because that I am using to show you this Lissajous figure, okay. So that if you take two signal and then if any phase difference is there between these two from Lissajous figure, you can find out this. So that's what I was showing you. Okay. Okay. So different figure, with time it is changing, Why? Del omega, because of del omega t. But I think this is the for same frequency. If I take different frequency, as I told, this also I can make static, but there I have to change the frequency, right? So this I can do, just this I can do using a same signal. So this basically, this from this I am taking signal, this one, okay, and another same signal I have used this circuit, okay, LC, I think this one shear circuit, okay, this shear circuit we have used. So another signal, same signal we are taking through this shear circuit and putting here. So that signal will putting here. So they are of same frequency. Okay, dual mode I will